Warning: butane is extremely flammable. Bromine is very corrosive and toxic. Wear gloves and a respirator when handling them. Hi guys, this is MIH. Quick lab notes update before I get on with a large organic synthesis project. I recently made potassium dichromate and the reaction produces a small amount of bromine as a byproduct. As we all know, bromine is notorious for its difficulty to store, so I decided to use it right away in a test experiment, which is the bromination of butane. I moved outside and took out a conical flask, a bottle of saturated sodium chloride solution, and a can of butane lighter refill gas. The conical flask and the sodium chloride solution were chilled in the freezer to negative 18 degrees Celsius prior to the experiment. I took around 20 milliliters of butane from the spray can. A decent part of the butane vaporized into the air, but I still can obtain some liquid butane in the flask. I then quickly added 2 pipettes of liquid bromine into the butane and filled the large beaker with the saturated salt solution to cool things down. The transfer must be done very fast since both butane and bromine are very volatile even at those temperatures. I placed the flask under sunlight and small bubbles started forming in the flask, indicating that the reaction started. The light splits bromine molecules into 2 bromine radicals, which attack the carbon-hydrogen bond in butane and starts a radical chain reaction, producing bromobutane and hydrogen bromide. The hydrogen bromide is not soluble in butane and bubbles out. The reaction is exothermic and proceeds faster and faster over time. An interesting thing about this bromination reaction is that the product is almost exclusively 2-bromobutane, while the chlorination reaction produces a mixture of 2 isomers. Bromine radicals are less reactive than chlorine ones, so it has chance to differentiate between the more stable secondary carbon radical than the less stable primary carbon radical, and selectively combine with the former. As the reaction slowed down, I shined a UV light onto the mixture to aid the reaction and speed it up. I expected all of the bromine to be consumed and ending up with a clear mixture, but after their reaction a lot of bromine still remained. I added some more butane and the reaction kicked off for a while but stopped again. I'm not sure what is happening here, so I'd really appreciate any explanations. Anyways, I decided to stop the reaction and harvest my product, 2-bromobutane. I added some water to some potassium carbonate and shook the beaker until the solid dissolves completely. If we take a look at the reaction mixture, you can see some droplets floating above the brown liquid underneath. I added the potassium carbonate solution into the flask slowly and vigorously shook the flask to destroy all remaining bromine and hydrogen bromide. I pipetted the lower yellowish layer of our product into a small vial. Then I added some diethyl ether to the flask and shook it, which will extract any remaining product. The lower water layer is then removed into a beaker and heated to boiling, which removes all organics and the residual bromine. I recycled the potassium bromide in it by adding it to the bromate cell. The ether layer is stored in a vial with the product. The yield is much lower than I expected, probably due to the butane and the bromine evaporating away too fast. Despite the reaction's failure, I'll perform other, more accessible radical halogenation reactions in the future. Thank you.